Imagine you are baking chocolate chip cookies and you want to make as many as possible so you can share them with all your friends. Well, you look at the recipe and it calls for 1 cup of chocolate chips and 2 eggs for each batch. And you check your pantry, you check your refrigerator, and you find out that you have 3 cups of chocolate chips and 4 eggs. Well, looking at just the chocolate chips, you could make 3 batches. But because you only have 4 eggs, you can only make 2 batches, and therefore eggs are your limiting reactant. The limiting reactant limits the extent of the reaction, and thereby determines the amount of product. A portion of all the other reactants remain after the reaction stops. These leftover reactants are called the excess reactants. This concept is important to learn because generally, in nature, the reactants in a chemical reaction are rarely present in exact ratios specified by the balance equation. It is important to know which reactant is the limiting reactant because the amount of product formed depends upon this reactant. For example, with the chocolate chip cookies, you can only make 2 batches even though you have enough for more if you looked at the other ingredients, but you don't have enough for more with just eggs. Therefore, learning how to identify the limiting reactant is vital in both chemical reactions and in real-world situations like baking. It's not just enough to know what the limiting reactant is and what the excess reactant is, though. You have to know how to determine which reactant is limited and by how much. So, for example, if you had 10.0 grams of hydrogen gas, and it reacted with 10.0 grams of sodium oxide, what mass of hydrogen oxide is produced? The masses of both reactants are given, but you must first determine which one is the limiting reactant, because the reaction will stop producing product when the limiting reactant is used up. First, you must write out the chemical reaction and balance the equation. So H2 plus Na2O yields to H2O plus 2 Na. Alright. Then, using stoichiometry, you can determine which is the limiting reactant. So let's start off with the hydrogen gas. You need to convert the 10.0 grams of the hydrogen gas to moles. You can do this by using the molar mass. And remember, what you want is on the top. So you want to put 1 mole on the top, and the molar mass, which is of hydrogen gas, which is 2.02 grams, on the bottom. Then you want to use the mole ratio. Using the mole ratio involves the coefficients in front of the numbers of the balance equation. So you can't see it, but whenever you can't see a coefficient, it means 1. So the coefficient in front of the hydrogen gas is 1, and the coefficient in front of the hydrogen oxide is 1. So therefore, the molar ratio would be 1 mole of H2O, which is what we want on top, all over 1 mole of hydrogen gas. Now finally, you want to multiply this all by the molar mass of the hydrogen oxide again, because that's what you're looking for and you want it in grams. So you put how many grams of H2O on the top, all over 1 mole of it on the bottom, and the molar mass of H2O is 18.02. And now, you can do these in separate stages, but I like to write it all out in one long line because it makes the multiplication and division a lot easier. You can just do 10 times 18.02 divided by 2.02. See, one nice long line, and that's equal to 89.2 grams of H2O. Now, you want to do this again to find out the limiting reactant, because we found out how many grams, if you have 10 grams of hydrogen gas, it will produce 89.2 grams of water. But now you want to figure out, well, you have 10.0 grams of sodium oxide also, right? How many grams of water will that produce? And whichever one produces the least amount of water is the limiting reactant. So again, you multiply this by the molar mass, so 1 mole all over, for sodium oxide, the molar mass is 61.98 grams, and A2O. You multiply that by the molar mass, so 1 mole H2O all over, sorry, not the molar mass, the molar ratio, which is the coefficient. So again, you have 1 mole of H2O and 1 mole of Na2O. And the coefficients are often invisible when the number's 1, but when you don't see them, it just means that it's 1 over 1, essentially. So then 1 mole of Na2O, multiply that by the molar mass of water all over 1 mole. And then, because it's nicely written out in one long line, you can do multiply all the numerators together and then divide by the denominator. And you will get 2.91 grams of H2O. Now the limiting reactant is sodium oxide, and you know this because 10 grams of sodium oxide can only produce 2.91 grams of H2O, but 10 grams of hydrogen gas produces 89.2, which is a much bigger number, but if you only have this much of each, you can only make 2.91 grams of water before the reaction is complete. So once the limiting and excess reactants have been identified, we can figure out how much excess is left. So we can take 2.91 grams of H2O, because that's the total amount made. You can't make any more of that due to the limiting reactant. You can write that down, 2.91 grams of H2O. And then you can multiply that by the molar mass of H2O, which is 18.02 grams. And then you want to use the molar ratio. So the molar ratio in this case, you put, the excess is H2, so that's what you're looking for on top. 1 mole of H2 all over 1 mole of H2O. Okay, and now in this case the molar ratio is 1 over 1. It's not always like that, but because of the coefficients in front of H2 and H2O being invisible technically, that makes them 1. Now if we were solving for Na, sodium, then the coefficient on top would be 2. Anyway, so once you've figured out the molar ratio, then you multiply that again by the molar mass of hydrogen gas to figure out how many grams would be left. So you have 1 mole of H2, and on top that would be 2.02 grams of hydrogen gas. So this is the exact same process, if you've seen, as the same way that we identified the limiting and the excess reactants. Same process. So now we will multiply all the numerators together, so 2.91 grams of H2O times H2 and divide by 18.02 grams. And when you write this equation correctly, you know that you can cross out grams and grams, H2O and H2O, and moles, and so your final answer will be in grams of hydrogen gas. So multiply and divide, and you should get it's equivalent to 0.326 grams of hydrogen gas, and that's how much excess you have.